welcome to the second module for our lab sessions. So here we are, the other day we have shown the gowning procedure. So my colleague Haripriya demonstrated that complete gowning procedure. Today you can see I am inside clean room. So I am completely gowned as far as we discussed the other day. Like in that module we have mentioned that you have to wear your mask, then hairnet, then shoe cover, then your suit, then you have to make sure that your hair or any part of your dress should not come out, then you should wear gloves and come in. And here I also mentioned that we are using thin nitrile gloves for this purpose. So that is basic gowning procedure. But if we want to use any wet benches, so based on that wet bench, what are all chemicals we are using, like whether that is acid or whether that is solvent, based on that we have different types of gloves or different set of PPEs available for further protection. So after this basic thing, so if you see here, today we are going to use this acid bench and we will demonstrate piranha cleaning of a 3-inch silicon wafer. This 3-inch silicon wafer, using this 3-inch silicon wafer, we will be demonstrating the further processes, like complete fabrication process of one of the devices for neural recording. So here, as you see, after this, if we use any acid bench or any wet bench, there is a fair chance of spillage. So usually, with practice, you will make sure, or you will be more used to use the chemicals so that you will not spill. But there is a fair chance that it may spill by accident. So I should have one apron on top of it. And these gloves, as I already mentioned, that this can handle only it cannot handle the strong acids or strong base. So for weak acid and base, this is fine. However, we are showing piranha solution today, preparing piranha solution today. So as we will be using concentrated H2SO4, this is always better, or it is mandatory to wear one more thicker nitrile gloves, and if required or if you feel, you can wear acid gloves as well, dedicated acid gloves. So now I will be, so here are the dedicated acid gloves. You can see this is the short one, or even we can have a long one so that our hand will be covered. However, at least one thick nitrile gloves on top of these thin nitrile gloves is mandatory. So here I'll just wear other PPEs so that I can start the process. So another point is these gloves can save you from the acid, and the apron can save you from the spillage, by any accidental spillage. However, we need to protect our face also. For that, face shield is mandatory when you use any of the wet benches. So let us wear the other PPEs, then we will come back to the bench again. Similarly here, we will wear the gloves at the last, so that we can confirm that it is cleaner than the other parts, like than apron or than the face shields. So as you have seen that I got my gown, then face shield. Face shield must be covered from this angle also, so that nothing can go inside, and this will help you from the fumes as well. Okay, now you can see my face is protected. And as I already mentioned the other day, sleeve should be below the gloves, so that first reason is the dust or the dust generated by you or from the skin or from the clothes should not come out. That is one of the reason. It will be contained inside. And the second reason is, if somehow spill happens, it will flow through, it will not touch your skin. And this is a thicker nitrile gloves. This can handle strong acid and strong bases. As I am going to use H2SO4 and concentrated H2SO4, so I am adding this. there are different type of gloves, and those are useful for handling different type of acids. Let's say if we want to handle HF, then we must have F-Talon gloves that will come at least till this much, so that we will be safe. So as we are showing that now we are done with the gowning for these particular benches. However, there is one more point. We cannot simply start any chemical process just after gowning. Thing is, if something happens to the person who is working, there must be someone else to take care or to ask for the emergency help. For that, buddy system is mandatory. And always, as a buddy, if you use wet bench, then buddy should be just next to you, not any other place in the clean room. We must be just next to you to help at any moment required. Okay, so Haripra is helping me in this process. She is buddy for the day, and you can see here when I am talking after wearing face shield, so this is getting kind of foggy, but you cannot avoid it because safety comes first. After that your process. So rely more on this. Don't think about whether it is foggy or not. As long as you can see the things and you can carry out with the experiments, your experiments.
Now, I have got my sample. This is a 3-inch silicon beaker. So now I want to get my sample clean. So let us move on to the details of the cleaning procedure. So Suman, can you please tell me how can I get my wafer clean? What are the types of cleaning that can be performed?
So as already mentioned in the theory classes or in the TA classes also, there are few like standard cleaning procedures like RCA cleaning, like RCA1 and RCA2, then piranha cleaning, even we can go for solvent cleaning. So here, as she wants to fabricate some device on this, better not to go with some solvent cleaning, because that is not that effective. So we will go with piranha cleaning first, because she is not using silicon as the device material, it is just as a substrate, and flexible devices will be on this silicon wafer. So we will show you the preparing piranha solution today and how to clean it. So here piranha solution is basically a ratio of concentrated sulfuric acid and hydrogen peroxide. So H2SO4 of 3 parts and H2O2 of 1 part. So we will mix it. So as we know that it is exothermic reaction, so you should make sure that the suction is on, so that whatever fume will be generated, that will leave this place, or it will not come inside the clean room and affect other processes. So for that you should make sure that suction is on first, and second you can switch on light for your better visibility. So now, as she has 3-inch wafer, so we will select the glasswares accordingly. Like we will be using petri dish, that will be okay for 3-inch wafers. And here, as we will be using acids for our process, so we should use plastic tweezers, and we cannot use any metal tweezer because that will react with the solution or the acid itself. So we can see here, whatever we have in this area, everything is plastic tweezers only. So we'll start our process. So before that we will check whether water supply is there, suction is on, and light is on. As the sample is here, you can see this white color cloth. This one is basically a lint-free cloth. So why lint-free? So if you remember yesterday while gowning, I just told you the materials that can shed inside the clean room, that is not allowed. So this is one type of non-shedding cloth. So non-shedding means it will not generate any lint, or it will not leave any lint on the sample or on the bench or inside the clean room. That's why we are using these lint-free clothes. These are anyway commercially available. So this is one part. So the second thing, see here, when we were standing in front of that hood, this lid was not up to this. However, this is always recommended that when you are working in weight bench, your head or your body part should not be inside the hood. You should be outside, standing little far, so that if any spillage happens, it should not affect you even after all these protections or after wearing all the PPEs. Here, that is why it is almost 70% closed. So we can easily work using this open area. Now, when we will prepare the sample or when we are not interacting inside, that time it will be almost closed or almost 90% closed. That is what it is recommended. And while working, it will be around 70% open. 70% closed and only 30% open. So now we have told about these tweezers, why plastic, why not metal, then why lint-free cloth in clean room. Then if we come to the glasswares. Okay, so glasswares or these petri dishes or maybe beakers, all these will be kept on the bench only. So, however, if you can take a closer look, you will see that we do not store any chemical on the bench or in this hood. That is recommended always not to store any chemical here, because that may lead to some safety hazard or may lead to some accident. So for that we are using these cabinets below this. So here these are the cabinets to store extra glasswares, oxidizer and the acids. Basically, as per the safety protocol, oxidizers and the acids cannot be stored in same cabinet. So if we see here, we have few glasswares. From this we need this measuring cylinder. So we are taking it out. And otherwise there are hydrogen peroxide. So this is the oxidizer. That we will be using to prepare this piranha solution. So we are taking this out for our purpose now. As glasswares and oxidizers are there, here we have stored the acids. So if you take a closer look, you will find here sulfuric acid, hydrochloric acid, orthophosphoric acid, and usually for our usage we usually keep it in small containers so that it will be little safer to handle and easier to handle. So H2SO4 is here. So another thing is, if you see, other than these glass measuring cylinders, we have this measuring cylinder as well, because if we want to use hydrofluoric acid or HF, from the theory classes we know that HF etches glass or silicon dioxide, so that cannot be used for measuring HF. So we have these plastic glass wafers as well, or PVC measuring cylinders or plastic measuring cylinders as well. Okay, so we are taking this H2SO4 container out from here to prepare the samples. So before starting any fabrication process, you have to clean your sample properly, and for that, cleaning this sample, first you should clean these glasswares, because whatever glasswares are here, that was supposed to be clean, because as per the protocol, always one user should leave the bench only after cleaning all these glasswares that he or she has used. However, if these are cleaned also, as these will be on the bench inside this hood, we cannot trust that cleaning. We should not trust that cleaning, and we should clean it once again before starting our process. So these are the glasswares I will be using. So as this is a 3-inch wafer, so we will be using these two petri dishes, one for preparing piranha solution, another one for DI water, and this one is the measuring cylinder where we will and this will be useful to measure and mix the H2SO4 and H2O2 in 3:1 ratio. Here is the DI water flow. We can check it before starting the process. So in all the processes, we will use DI water only. So for any of the fabrication processes, if you see that water is mentioned, that water is deionized water or DI water, not normal tap water. That is something that you have to keep in mind. So we'll start with cleaning the glasswares. Always it is recommended to clean any glassware at least thrice, and to ensure that any contamination will not be there when you are about to start a process. First, and whenever you are using a small size sample, better to use the small petri dishes for preparing your chemical, so your chemical usage or chemical wastage will be minimized, because for smaller sample size you do not need more amount of chemicals. However, if you use 4-inch silicon wafer instead of this, or 4-inch glass wafer instead of this, then you should use these 5-inch petri dishes. That is something you can use, but as we are going with only 3 inches wafer, so we are going for it. Next, so before starting any cleaning process or before preparing any cleaning solution, first you should have a good stock of DI water with you for emergency purposes. So these can be useful when you want to transfer wafers from here or your any of your samples from solution to water. It will be useful in that case, or in emergency situation or after usage you can just clean or dip your tweezer and clean it. If you clean your tweezer, then before placing the actual sample, you should discard this water and put fresh DI water there. Okay, so for piranha cleaning, we can say that we will do this cleaning process usually for samples for 10 minutes. So we'll prepare the solution, dip it, wait for 10 minutes, then we'll keep this here. So as I already mentioned, it is almost 30% open and 70% closed for our safety. When the solution will be prepared and we don't have to interact with this system, we'll keep this down even more so that almost 90% will be covered. Now let us prepare the sample. So as we know that it is 3:1 ratio H2SO4 and H2O2. Let us mix it, and always be on the safer side that you should not spill the chemicals on you as well as on the bench, or you should not. Okay, you have taken the H2SO4. Before pouring it, you should make sure that there is no water, otherwise there will be an exothermic reaction. So before that you should make sure about that. Okay, so then we will be using same measuring cylinder for measuring H2O2 also. So before that we should clean it once again or rinse it with their water. And as I mentioned, we'll do it thrice. So you will see whenever I will mix these two, as H2SO4 is on acid and H2O2 is a strong oxidizing agent, so it will be an exothermic reaction here and fume will start coming out. So as already we checked that suction is working, so after this we'll put that sample, or in our case that complete wafer here, and put this lid down. You can just take a closer view here. So here, while pouring it, you should not pour it exactly at the same place, everything. So you should spread it all over, because otherwise it will be a localized heating for and that may break your glassware. So you can see fume is coming out. You can just dip it and see lot of bubble is coming out. So basically whatever contaminants are there, those are getting cleaned. So here you should understand the application of piranha cleaning. So if we talk about the application, so if you are not using this silicon wafer or silicon as a device material, you can use this first, this cleaning process first. Secondly, if you want to use it somehow for photoresist stripping, or if you have any polymer coating on that, if you want to clean, then piranha is one of the best processes. Just keep in mind that it should not etch, or it should not destroy your actual required metal layer or actual layer also. Let's say you have a metal that reacts with piranha, then you cannot clean that sample using piranha solution. Okay, so you can just agitate it little bit, so that with agitation, so whatever bubble were formed on top, that will get clean. And as long as this is activated, let it get cleaned, and usually we do it for 10 minutes. So during the process we were agitating it continuously, just to ensure that whatever bubbles were forming on that should not be stagnant. Then these things can be redeposited, like whatever came out from that can be redeposited. So just made sure about that thing. Now you can see 10 minutes is over. So here is that wafer. We'll put it in water, and always you should agitate it. Okay, let this be in water for some time. And here we can see, so there was a lot of dust particles on that, that's why those many bubbles are coming out. And here so here is that cleaned wafer. So now let us come to the disposal of this. So as this is strong acid, so pH will be very less, close to 2, 3, something like that. But we cannot dispose directly here, like directly in our basin, if pH is around 6. So it should be more than 6 for the acids and less than 8 for the base. Then those will be like mild acid, mild base, then we can dispose it here. Otherwise we have to store it separately in a PVC container. So as of now we are just keeping it here. We'll store it in a PVC container after this process. Let us clean this wafer first. So this is anyway DI water. As I already mentioned, in clean room, water means DI water only. That is the only water available in clean room, because otherwise whatever ions are there, those will affect your process, or it can affect the conductivity of the wafer, and it can do a lot of things. So we have rinsed the wafer in DI water. So after cleaning, this is our cleaned wafer. We'll just show it here. So this is the clean silicon wafer after piranha cleaning. See, so how it was, and after cleaning, whatever is this now. Our next step is we have to blow dry with nitrogen gun and dehydrate it for 10 minutes before starting any process on that. And the dehydration bag will remove the moisture content that is here now. Okay, so this completes our piranha cleaning session. So that dehydration and this, we are not showing it here as of now, because in further modules, as a part of the mandatory process, we have to do dehydration bake and nitrogen blowing also. So this is how, after that we'll carry forward with this wafer, and we will show the next processes as well. So here are the clean wafers, as already mentioned. We'll see you in the next modules with the further processes, and till then we'll keep this wafer safe, and thank you. We'll see you in the next module.